All right, so in this video, I'm going to be walking through a workshop of how to build an NFT subgraph on top of Near Protocol. And the workshop that I'm going to be going through is open sourced here in my GitHub. So you can go to github.com/dabbit3 and you should see the Near subgraph workshop. So if you just go to my GitHub profile and go to my repositories, this should show up, or you can search for it here and we'll start going from here. So essentially everything that you can do here should be able to be just walked through. So everything that I have here should be copy and paste. I tried to explain a lot of this stuff here, and I'm going to also walk through it in this video. So to get started, the two things that we need to do is install the Graph CLI using either NPM or Yarn. And we also need to go to the Graph dashboard and go ahead and create a subgraph for us to deploy to. So to do that, we'll go ahead and get started. So I'm going to go to the graph.com. Here I'm going to go to products hosted service, and I'm going to go ahead and create a account or sign into my existing account, and then go to my dashboard. So what we want to do is click create or add subgraph, and then here we can go ahead and define the subgraph name and details that we'd like to work with. Now you can create a subgraph for any application or any contract or program that's been deployed to Near. The one that I'm going to be working with is the Misfits NFT contract. This is just one of the first NFT projects that I came across while Googling around. So I figured I'll play around with it, and it ultimately ended up what I built this workshop off of. You could also probably do this with any other NFT project that's out there. The metadata and stuff might be a little bit different, but everything else should be the same. So using this address, we can go to the Near Explorer, and here we have some of the information that we're going to end up using. For instance, we have the account name, we have the transaction where it was created, which will give us the start block and things like that, which we'll be using in just a moment. So with that being said, we can go back to our graph dashboard and we can just enter the name of the subgraph. So I'll call this something like Near Misfits API or whatever you'd like. You can also give it a subtitle and a description. So this will just be an NFT API for Near Misfits. And then I'm going to choose to hide this because I have already deployed one of these. So I'm kind of just walking through this to show how that was already deployed. So no need to show it for other people to find. And I'll click Create Subgraph. So once this is created, we can now use our access token and the Graph CLI to go ahead and build this thing out. So I'm going to go back to the workshop, and I'm going to go down here where it says initialize a new subgraph using the Graph CLI, and I'm going to copy this command and go here and just paste it in, npm install -g at graph protocol/graph CLI. I already have this installed on my computer. I'll just do it again for the sake of this workshop. And I'll just give this a few seconds to go ahead and can finish installing. All right, so once the Graph CLI is installed, you should be able to have the graph binary available to you. And then using this CLI, we can initialize a subgraph locally, which is going to be just a boilerplate project for us to continue working from. So I'll continue going here, and we're going to go down to this command right here where we run graph init, and then we're going to pass in some values there, some different commands like -- from contract will allow us to go ahead and just define the contract address, and then the contract name. We're going to be indexing tokens, so we'll just call the contract token. NFTs, non-fungible tokens. And then we're also going to be indexing the user that owns that token, and we're going to have relationships between the token and the user. So the protocol is Near. The subgraph name will be your username / the subgraph name in the dashboard. So if I go to the Graph Explorer, the Graph hosted service, I can go ahead and copy dabbit3 / Near Misfits API. It'll be your username / whatever this is. So I can just do that. The directory will just automatically default to that. I'm going to choose near mainnet. Contract account is what we passed into the arguments. The contract name is also what we pass into the arguments. And with that being said, we should go ahead and have everything we need to kind of get going. So I'm going to go back to the workshop, and I'm going to scroll down to this part where we define our GraphQL schema. And then once this is done initializing, I'll just go ahead and open this up in my text editor. All right, so I'll change into the near misfits API, open this up in my text editor, zoom in a little bit so everyone can see this. And here is our boilerplate subgraph that we're going to start working with. So what we have is three main parts. We have our GraphQL schema, which is our data model. So this is kind of like us defining the data that we'd like to have saved. So in the case of an NFT, you might save stuff like the metadata, the ID, the collection name, or whatever else that you have available to you based on how that contract was written. We also have the subgraph.yaml, and this is our subgraph configuration. So if you've ever done anything with infrastructure as code or just any type of configuration using YAML, you have a good understanding of kind of how you might define a YAML file. And a subgraph, we just have different flags for things that we'd like to kind of allow the indexer to know about the subgraph, and then they will essentially look at this information and kind of do different things based on what we've defined here. So we'll walk through that in just a moment. And then the last thing is our business logic. So the code that we're actually going to write is going to live in this mapping.ts. So this is assembly script, but it's very much like TypeScript or even, yeah, I would say TypeScript would be the closest thing. So if you're ever in JavaScript or TypeScript, assembly script is not too far off from there. It has its own quirks, but we're going to start just by deleting that, and we're going to be writing our own in just a moment. So the first thing there that we'll do is we'll go to our GraphQL schema, and we can just copy this schema, and I will walk through it just to kind of give you an idea of what's going on here. So I will first start with these two types down here, and then I'll get to this full text search modifier there, or that directive there. So the two pieces of data that we would like to be able to query for are tokens and users. A token will have its own set of metadata. So we're saying that a token should have an ID, it should have an owner that is relation to this user that we're going to also create. We're going to have an owner ID, which is just going to be the account that owns that token. We're going to have a token ID, which is going to be the unique ID for that token, obviously. We're going to have the image, so this will be the IPFS image for the NFT. We're going to have the metadata, and we're going to have the kind, which is a piece of metadata. So a token is going to have a metadata, and that metadata object is going to be different based on the NFT project. So in this project in particular, you have the kind and the seed. I don't really know what the seed really means, but I indexed it anyway. But the kind is kind of like a rarity. So, you know, some of these are more rare than others, and it's based on the kind. So the last thing that we are indexing in addition to the token is this user, and the user is just going to allow us to have a relationship, one-to-many relationship between tokens and users and tokens. So a token can have a user, and a user can have many tokens. And we will use these two directives to kind of make all this work. We have this @entity directive, meaning we're going to reflect that we're defining this entity in our subgraph.yaml, and the CLI will be able to pick that up and allow us to index that. And then we also have this @derived from directive, and this just allows us to create relationships, like in this case, a one-to-many relationship between users and tokens. And then finally, we add this optional, and this is optional, it's a full text search configuration. And in this case, we're saying we want to be able to search these tokens. So in this array, we're going to say include the entity of token, and then we want to make these two fields searchable, the owner ID field as well as the kind. So this will allow us to kind of search for tokens based on their rarity. So we'll look at how that works in just a moment. So with that being said, we can save the schema and then close that file and then open the subgraph.yaml. The first thing we'll do is just update this to be 00.4. When you watch this video, we might have already updated the CLI, but this is just going to add some certain features that we're going to be using here. And also, it's just the way that we're going to be configuring our subgraph.yaml. We will need to have that spec version to be 0.4. So we want to next go to our entities, and here you can see that we have the entities defined as token and user, and those should match our GraphQL schema. So we have our token and we have our user. So here we should be able to go here and say token and user. So that's just how we match up our entities with our data model. The next thing that we're going to do is we're going to add the start block, and this will allow us to kind of know where we need to start indexing. So this way we don't have to start from the very beginning of the chain. We can start at this block, and then it will just make it a lot faster. And you can find this start block on any contract just by looking at where the contract was deployed. Next, we're going to enable a couple of features. So I can add these feature flags. So below the schema definition, I'll add features. One feature that we want to add is full text search, which is something we set up here. And we also want to add this feature called IPFS on Ethereum contracts, meaning that we want to be able to essentially, and maybe that naming with Ethereum shouldn't be there since this is near, but maybe we'll update that. But essentially what we want to have access to is the IPFS API. So when we're in our mappings where we're writing our business logic, we're going to be mainly interacting with a couple of different data sources or APIs, you could say. So the mappings, again, this is where we write our business logic. This is where we actually save information to the node and make it available for querying. So when you think of a smart contract that's been deployed, whenever someone interacts with that contract and creates a write operation, we have a transaction, right? So every time a transaction is fired, we have the option to call functions, and then we can handle those functions in this mapping. And in the mapping, we can do stuff like save to the node based on the information that comes in to the arguments of that mapping. And in our case, in near, we have these receipts, and we're going to basically have a function that calls handle receipt. So every time we get a receipt from a transaction, we're going to handle that in this mapping. So in the mapping, we're going to be essentially calling IPFS to use the token ID along with the hash of this IPFS contract, or I'm sorry, the IPFS address for where this NFT project was deployed to read that metadata and be able to fulfill these two fields in our type. So we need to get the kind and the seed, and the only way we're going to get that is by reading from IPFS. So therefore, we're enabling IPFS. So hope that wasn't too confusing the way I just said that. The next thing we can do is just kind of like double check and make sure we have everything set up. I believe we do. So we have everything ready to go. And now we can do the last thing, which is going to be our mappings. So the mappings are going to be a lot of code that we're going to write here. And actually, I did skip a part. We need to run this command called graph codegen. And this is essentially going to create some APIs that we're going to be importing right here for us to interact with the graph node, which is essentially how we're going to be saving this information to the node. So all I need to do is open the CLI, and I can run graph codegen. And this will go ahead and generate some code for us. And if that runs successfully, you should be able to have these imports. So let's go ahead and import this stuff and make sure that that looks like it's working properly. And it looks like it is. We don't have any errors. So we are importing from two different places. We're first importing from the graph TypeScript library. And this just gives us a bunch of APIs and types for us to use as we're writing our business logic. So this will have some types for near. These are different APIs that allow us to do stuff, within our code. And then we have a log, which will just allow us to essentially do a console.log. We also have we have a token and a user API that allow us to talk to the graph node. So this will really be us just saving information to the graph node, or if we'd like to, also reading information from the graph node. The next piece of code that we're going to write is the handler function. So we said in the subgraph YAML that we have this handle receipt, and this will fire every time a new transaction is written. And then when that function is called, we can do whatever we'd like. So what we're going to end up having available to us is this array of actions, and then we're going to map, or I would say loop over every one of those, and then we're going to call another function passing in the index of that action along with the receipt. And then we can just write that function here. And I will start by grabbing just this portion of this code. So here we're going to be getting a couple of arguments. We're going to have the action as well as the receipt. And we will then be able to kind of write our business logic. So the first thing that we're doing here is we're going to first check to see if the the action is a function call. And those are the only ones that we're kind of interested in. So if it's not, we're going to go ahead and automatically return. If it is, we'll continue on. And then this is where we're going to be able to do stuff. So I will go ahead and create a few variables. So we'll create a variable setting it to the argument here coming in here, the receipt with outcome.outcome. We'll also get a reference to the function call name. So if we go to the smart contract, or I'm sorry, the address here, and we scroll down, we can see that we have different method names. So we have NFT approved, we have buy, we have all this other stuff. So what this is going to be the name of that function call. And then of course we can click into here and see details like the arguments and stuff that we're going to be also considering in just a moment. We also have the IPFS hash. So this is really where the NFT project chose to deploy to IPFS. I got this off of this near marketplace, or this NFT marketplace. So if we go to ipfs.io/IPFS/ this contract, or this address, this hash, and then we say like 123 or 234 .png maybe, then we should see one of these NFTs, or we can say .json. So these are the two different things that we're going to be working with. We'll work with the JSON metadata as well as the image, but we need to have the base hash in order to do that. And then all we really need to do is get this ID off of the argument that's coming through here, so the token ID. And then using that combination, we can kind of get everything we need. So that's what's going on so far. So here we're getting the string value of this function call, which is going to be how we determine whether or not to call the next function. So with that being said, we'll go back to the workshop. And now we're going to check, and we're only going to choose to proceed for a couple of different actions, or a couple of different methods. So there's a lot of methods that will be called in this program, or in this account, in this contract, whatever you want to call it. And we can choose to do stuff based on which function and which data that's coming in. So the two that I'm choosing to work with are buy or mint one. And the reason I did this is that these functions are going to be called if someone mints a new token, or if someone buys a token from a marketplace. I guess another way you might want to do this is if someone just transfers one as well. The logic should all be the same, but I left off that. So if one of these different methods are called, we want to go ahead and save that information to our node. So that's the only actions that we're going to be taking into consideration, or the only methods. So what we're going to now do is we're going to have this array of logs that are part of this function call, and we're going to map or loop over those. And using the information in this log, we're going to be saving or reading data from the graph node. So what that log might look like, if we go to the Near Explorer, you can see it will look something like this, where we have all of this this information here. So we'll have like the owner ID, we might have the contract ID, we'll have the token ID. We have all of this stuff, maybe the price. So we can use all this information out of the log that we're going to have access to. And to do that, it's going to be coming in as a string. So we essentially just need to parse that and then use it and turn it into an object. So we're going to first take the item and turn it into a string. We're going to log it out. This is optional, of course. We're going to then basically take out some text that we don't need. So it's going to be shaped as an object, and it's also going to also have this prepended event JSON. And what we really want to do is just remove that event JSON and then turn that string into an object. So what I'm really doing here is I'm saying, okay, let's get this string, let's remove event JSON, and then the string we have now can be turned into an object. It's in the right format for us to do that. So I will then parse that and turn it into an object using the APIs that we have available from the Graph TypeScript library. And now we have this JSON object, and we can now start reading information from that object. So what I'm going to do here is we're going to say we want to get the data object, or the data property off of this object. And if this data exists, we're essentially doing a null check here. Then we want to continue on. So this is where all of most of the logic that we're doing next is going to exist. We first are going to now create an array or reference the data coming in here and turning it into an array. We're going to then take the first item in that array and turn it into an object. And now we have a new object that will have some of the metadata that we were just looking at, stuff like this made available to us. So the two properties that we're going to be getting off of it to be working with are going to be the token IDs and the owner ID. And the token IDs should be an array of just really one item. So we're going to go ahead and get those two values, the token ID and the owner ID, and we're going to now work with those values, and we're going to then check to see if they exist, because if they don't exist, we'll just return. For whatever reason, they should exist though. All right, next we'll go ahead and, whoops, get back up here. There we go. We're going to take those token IDs and turn them into an array. We're going to then take the 0th item, or the first item, and then turn it into a string. And then now we can call out to the graph node to load that token ID, because we have that token ID, and we can basically check to see if it exists already. Because if it does exist, we can assume that some of this data is already there, but if it doesn't, we can go ahead and add it. So we'll see if the token does not exist. What we want to do is create this token and save it to the graph node. So we'll go ahead and copy this here. We'll create a new token. We'll set the token ID property. So you could think of this as like an object. We're kind of like creating a token, and we're calling the dot. We're setting the dot token ID of the token ID property. We're setting the image property, and we're using that IPFS hash. We're adding the token ID.png for the image, and we're adding the IPFS hash /token ID/JSON for the metadata. And we can now set both the image property as well as the metadata using that IPFS hash. And let me make sure I copy that right. Maybe we need one more closing object. Okay, there we go. So now that we have the metadata, we can call out to IPFS. So here we're doing that. We're saying IPFS.cat. We're passing in the metadata. And if there is a result here, we're going to then turn the result into an object, and we're going to see if that value exists. And then we're going to now have this object that should look something like this. So this is kind of the object we're now working with, where we have a kind and we have a seed. So with this object, we can get the kind. If the kind exists, we'll save it. We'll get the seed. If the seed exists, we save it. And now we'll continue on. And these are the last lines of code we should have to write. And I will make this, there we go. Actually, this might need to go here. There we go. A lot of code. Okay, cool. So now that we've created the token, or we know that the token exists, so we've either created it or loaded it, we now update the owner ID, because if this was a transfer to someone else, we want to update that, and we also want to update the owner. So we update those two values, or set those two values. We then check to see if this user already exists. If they don't, we go ahead and create that user, and then we save both the token as well as the user, and then we're done. Everything is ready to go now. We should be able to kind of start querying both tokens and users. So we've taken into account, hopefully, whether the token exists or the user exists, and saved both of those. So if we go ahead and save that and close that, we should be able to now test our build out to make sure that we don't have any logic or anything wrong in our assembly script mappings by running graph build. The CLI will actually automatically run this when you try to deploy a subgraph. All right, so it says build completed. What we can now do is deploy and see if this subgraph actually works. So to deploy the subgraph, we need our access token. So what I can do here is go copy my access token, and we can now run this command here. So we can say graph auth, and I can paste that in. And then I can copy the access token here. And then if this is set properly, it should just tell you that the deploy key is set. Next, what we can do is we can just run yarn deploy. And yarn deploy should package everything up. And if all of our code is right, it should go ahead and deploy. All right, so everything looks like it worked properly. So if I go back to the dashboard and I refresh, we should see that it's syncing. Now, I've already deployed a similar API to this, so it should pick up that the data is the same, actually, or maybe it doesn't. I think because I'm maybe starting from a completely new API, actually, so it's not going to do that. But you will see that it's starting to sync, and as entities get saved, this number will go up, and you will begin to be able to start querying for data just like this. So I can go to, and it honestly will only take a couple of minutes before you'll start seeing data, because you can go to the logs and kind of see the progress. But it's kind of like warming up right now and getting everything going, and it'll start looping through all the transactions. But if I go to my dashboard and I go to near misfits, which is where I deployed this earlier, you can see that it's already been deployed somewhere else and it's working. So we have this way to query now, and I can now just like maybe query for tokens, getting the ID, the owner ID. I might ask for the image, the metadata, and the kind. If I copy this image, I should be able to go to IPFS IO / and there we go. We see our image there, the same with the metadata. Here we go, we see our metadata. We also have that full text search. So in our subgraph, I believe we called that something like token search, which is the name of the search. So if I go here and I say token search, I can now pass in text, and I might say I want to look for only meerkats, because you have normies, meerkats, and a bunch of other different kinds. So let's say we only want to search for meerkats, and we want to get like the image, the token ID, and maybe the user and their tokens. Or is it the owner? All right, cool. So now we're basically going to do a full text search. We're going to return the image, the token ID, and the owner, and we're going to return the owner's tokens and the token IDs that they own. So this is a little bit more of a complex query. And here you see that we have the image coming back, we have the owner, the tokens, all that stuff. So, you know, it will take maybe 5 or 10 minutes before that should show up on your subgraph after you've deployed a brand new one, but I will check back anyway just to see if we see anything. Yeah, not quite yet. But as long as there's no error, you should be good to go, as long as you've gone through the code that we went through there. So that's it. If you have any questions, we have the Graph Discord. Definitely go there, check it out. I appreciate you checking out this workshop. And if you have any issues on the workshop as well, definitely feel free to open them up. This is GitHub, and I'd be happy to try to address those as soon as possible. So thank you, and good luck.